Dear viewers, we solve hundreds of small problems every day. A major goal of education is to help students learn in ways that enable them to use what they have learned to solve problems in new situations. In short, problem solving is fundamental to education because educators are interested in improving students' ability to solve problems. This entry defines key terms, types of problems, processes in problem solving, and then examines various approaches in problem solving. An important cognitive goal of education, formal and informal, in every educational context is problem solving. Therefore, the instructional design and technology community should learn how to design problem solving instruction. In order to support those efforts, instructional design and technology researchers should conduct high quality research on learning to solve problems that will enhance problem solving learning experiences for all students. Hence, it becomes necessary to identify different kinds of problems and the approaches to problem solving. A problem exists when a problem solver has a goal but does not know how to accomplish it. Specifically, a problem occurs when a situation in a given state, a problem solver wants the situation to be in a goal state and the problem solver is not aware of an obvious way to transform the situation from the given state to the goal state. Now let us see what is a problem. In his classic monograph on problem solving, the Gestalt psychologist Karl Duncker defined a problem as follows. A problem arises when a living creature has a goal but does not know how this goal is to be reached. Whenever one cannot go from the given situation to the desired situation simply by action, then there has to be recourse to thinking. Such thinking has the task of devising some action which may mediate between the existing and desired situations. What are the different types of problems? In school and in everyday life, we all have to solve a wide variety of problems. In school, these problems might be how to complete an algebraic equation or remembering the order of presidents of India. In everyday life, problems might be how to maintain a long distance relationship or how to pay bills on a limited income. Either way, in order to be successful, we must have the ability to solve different types of problems using different types of solution strategies. Educational psychology has broken down problems into two different ways. The first way is to make a distinction between well defined and poorly defined problems. A well defined problem is one that has a clear goal or solution and problem solving strategies are easily developed. In contrast, a poorly defined problem is the opposite. It's one that is unclear, abstract or confusing and that does not have a clear problem solving strategy. For example, imagine that you are in school. If your teacher gives you a quiz that asks you to list the first 10 presidents of India in order and name one important historical fact about each, that would be a well defined problem. The instructions and expected outcome is clear and you can use a simple memory recall strategy to come up with the correct answer. However, if your teacher gives you a quiz that instead asks you think about some history, then draw a picture and be sure to wash your hands, you are not really sure what to do. What does the teacher expect of you? This is a poorly defined problem because you don't know how to reach a solution or answer. The second way that educational psychology has broken down different types of problems is by making a distinction between routine and non-routine problems. Just like the name indicates, a routine problem is one that is typical and has a simple solution. In contrast, a non-routine problem is more abstract or subjective and requires a strategy to solve. Routine problems are what most people do in school, that is, memorizing simple facts, how to do addition and subtraction, how to spell words, and so on. However, in more advanced years or in more advanced subjects in school, teachers might present students with non-routine problems that require critical thinking skills and subjective solutions. For example, the ethics of social issues such as the death penalty or the role of civil rights in laws or themes in famous literature might be considered non-routine problems. Non-routine problems require more complicated or creative problem solving strategies. Let's talk about problem solving strategies now and go over several possible options. What is problem solving? Problem solving is the application of ideas, skills, or factual information to achieve the solution to a problem or to reach a desired outcome. Let's talk about different types of problems and different types of solutions. According to Mayer and Wittrock, problem solving is cognitive processing directed at achieving a goal when no solution method is obvious to the problem solver. This definition consists of 4 parts. Number 1, problem solving is cognitive, that is, problem solving occurs within the problem solver's cognitive system and can only be inferred from the problem solver's behavior. Then comes problem solving is a process, that is, problem solving involves applying cognitive processes to cognitive representations in the problem solver's cognitive system. Then problem solving is directed, that is, problem solving is guided by the problem solver's goals, and problem solving is personal, that is, problem solving depends on the knowledge and the skill of the problem solver. In sum, problem solving is cognitive processing directed at transforming a problem from the given state to the goal state when the problem solver is not immediately aware of a solution method. Now let me see an example. Problem solving occurs when a high school student writes a convincing essay on the causes of the Second World War, understands how the heart works from reading a biology textbook, or solves a complex arithmetic word problem. Now let me see some problem solving strategies. Depending on the type of problem, you have a lot of options regarding possible solution strategies. In this lesson, let's start with the strategies that are common for different types of problems. Algorithm. The first strategy you might try when solving a routine problem is called an algorithm. Algorithms are step-by-step strategies or processes for how to solve a problem or achieve a goal. For example, when you are learning about how to take apart and clean a car engine, You will want to approach this problem using a set series of steps, making sure that you don't misplace or mix up any of the parts. The next is heuristics. Another solution that many people use to solve problems is heuristics. Heuristics are general strategies used to make quick, shortcut solutions to problems that sometimes lead to solutions but sometimes lead to errors. Heuristics are sometimes referred to as mental shortcuts, and we often form them based on past experiences. You have probably used heuristics all the time in your daily life, maybe without knowing what they are called. For example, when you go to the store to buy a product, there will probably be several options on the shelf. When trying to decide the quality of the different choices, many people use the heuristic rule. You get what you pay for, meaning more expensive items will be of higher quality. While this might be true in many cases, it's not necessarily always true. So, using this strategy does make a quick decision, but it could backfire. According to Mayer and Wittrock, students need to have 5 kinds of knowledge in order to be successful problem solvers. They are facts, knowledge about characteristics of elements or events, such as there are 100 paise in a rupee. Then concepts, knowledge of categories, principles or models, such as knowing what place value means in arithmetic or how hot air rises in science. Next is strategies, knowledge of general methods such as how to break a problem into parts or how to find a related problem. Then procedures, knowledge of specific procedures such as how to carry out long division or how to change words from singular to plural form. And then beliefs, cognitions about one's problem solving competence, such as I am not good in math, or about the nature of problem solving. That is, if someone can't solve a problem right away, the person never will be able to solve it. Now let me see some of the problem solving approaches. Are you about to start working on a problem? If you are starting the work on a problem, or if you are stuck and you do not know how to progress on a problem, try to understand the problem. Ask the following questions: what is given and what is to be found? Is it possible to draw a picture or a diagram of the context described in the problem? Can you paraphrase the problem? Can you come up with specific examples corresponding to the problem? The next approach, have you thought out an approach to attack the problem? If the general approach to solving the problem is obvious to you, create a plan to solve the problem based on this approach and carry out this plan. If you know a related or similar problem, you can use the knowledge of solution of the related problem to come with a plan. Otherwise, you may be feeling stuck. Are you feeling stuck? Many different approaches can be tried to get unstuck. One approach is to try working a simpler version of the problem and use the solution to the problem to get insights that are useful in solving the original problem. When you come a surprise or an aha moment, try studying the observations that triggered it in more detail and try observing how these could be used in progressing on the problem. Alternatively, you may just try to understand the problem better and use relevant suggestions. If you are discouraged with a few failed attempts, read this quote from the famous scientist Edison. An assistant asked, "Why are you wasting your time and money? We have had failure after failure, almost 1,000 of them. Why do you continue to pursue this impossible task?" Edison said, "We haven't had 1,000 failures. We have just discovered 1,000 ways to not invent the electric light." Are you busy working out details? Monitor how you are progressing and backtrack if needed. Do not forget to look for patterns, the unusual and surprises, that is, aha insights. Look for any surprise, understand it and its implication for the problem. Are you done solving a problem or a sub-problem or inferring a key conclusion? Critically examine your hypothesis and solutions. Done solving the problem? If it works, check each step. Can you see clearly that the step is correct? Can you prove that it is correct? Learn from the reflection. Specialize or generalize heuristics, that is, including metacognitive heuristics. Learn new heuristics. If the plan does not produce solution in a short time, then check from time to time. Why are you doing? What are you doing? Are you progressing? This is self-monitoring. If your plan fails, examine why it did not work. Writing with a rubric or a template can help in recalling and studying what you have done so far. Organize the information. Ask, can you conclude about the approaches that won't work? What else did you learn? Did you see any patterns? Are you about to communicate your conclusions to a teacher or to partners? Final part of your work on a problem is to communicate your conclusions. What is communicated may differ depending on the situation. Sometimes you are expected to report only the answer to the problem. Sometimes you are expected to show your work. Sometimes you may be doing collaborative problem solving. In collaborative problem solving, it is important to be a good communicator. Helping others on problems that you have solved can help you develop skills needed to become a good math communicator. The aspects of such communication include explaining your solution to someone else clearly, understanding someone else's solution, and providing feedback on it at various levels of detail. After you create an explanation for your solution, examine carefully if you have justified each step in the work. What are the various general approaches in problem solving? Though there are different approaches in problem solving, there are two basic approaches in solving problems. One is where the cause or the source of the problem is attacked, and the other is where the effects or symptoms of the problem are attacked. For ease of remembering, we can call these the stop it and the mop it approaches respectively. Each of these approaches has three basic forms. As we detail these approaches and their forms, let's use the problem of a leaking water tank to illustrate each one. The first approach, stop it. A stop it approach is designed to cure a problem so that insofar as possible the problem no longer exists. Its three forms are prevention, elimination and reduction. The first form, prevent it. By preventing a problem from occurring or recurring, we have perhaps the ideal solution. For example, If you can prevent a cold, you will not have to deal any further with a problem or its effects. The next form is eliminate it. Eliminating a problem once and for all is also an excellent way of attacking a problem. Elimination solutions can be expensive, however, so that they are not always feasible. The next form of stop it approach is reduce it. As we mentioned earlier, some problems like trash production cannot be eliminated entirely. In such cases, a strategy of reduction can be highly effective. Almost any problem can be made less of one by reducing its size. For example, current approaches to the flow of illegal drugs into the country include reduction strategies. The flow of drugs cannot be eliminated as long as demand continues, so interdiction focuses on as much as possible. The second broad approach is mop it. A mop it approach focuses on the effects of a problem. Instead of treating the leak from the water heater itself, we mop up the water on the floor, the effects of the problem. In this mop it approach, we may use treat it. Here, the damage caused by the problem is repaired or treated. For example, some of our drug and alcohol treatment programs are aimed at symptomatic relief of the effects of these problems rather than at eliminating the problems to begin with. The next is tolerate it. In this form of mop it approach, the effects of the problem are put up with. In our leaky water heater example, we might install a drain in the floor or waterproof the flow. The effects are taken for granted and measures are taken to endure them. The next form of mop it approach is redirect it. Here, the problem is deflected. Sometimes the problem will simply be redefined as not a problem. It's hard to think of a legitimate redirection for our leaking water heater problem, but suppose that the leak is small and the floor is not being damaged. We might say, well, we need the humidity. The leak is actually a good thing. Remember that a problem is a problem only when someone defines it as such. Sometimes, as when you get a cold, a mop it solution is all that's available. There is no elimination solution that works yet. In general, however, be careful to investigate the possibility of implementing a stop it solution before you focus on mop it once. There is a temptation to focus on symptomatic treatments for our problems when we should be looking for treatments of the underlying causes. Now let me see how to improve our problem solving skills. Here are 5 steps to improving the problem solving skills. The first one is define each problem in detail before trying to solve it. Take time to understand the problem, understand the criteria for a good decision, and generate some good options. The next step is offer one or two firmly suggested solutions. Offering too many suggestions will only confuse your client and allow him to become indecisive. Be very clear on the direction you offer with your solution and ask the person or team you are supporting to repeat it back so that it is clear. Next is prioritize your client's action steps to help avoid overwhelm. If your client agrees to take action, ask him to relax and focus on moving forward. Be sure that the action steps required are doable and achievable in a timely manner. The next step is implement a step by step plan of action. When you approach a problem systematically, you cover the essentials each time and your decisions are well thought out, well planned and well executed. Provide a checklist and mark off each item as it is achieved, so that others feel that they are achieving their goals and moving away from problems, obstacles and challenges as they take action steps. This will keep them motivated and in motion. The last step is look for more ways to improve upon the problem solving idea to avoid future problems. Continue to perfect your problem solving skills and use them for continuous improvement initiatives to serve your clients' needs. The more effectively you solve problems, the more value you create as the go-to authority. Let's summarize this topic. Problem solving steps can help you break down and begin to solve complex, thorny problems. Before trying to solve the problems, it is advisable to identify the kind of problem you are facing. Hence, in this lesson, we have seen different kinds of problems, the approaches to solve those problems, and also the steps to improve the problem solving skills. Thank you.